These are the solutions for the study guide for Chapter 4, Section 4 and Chapter 4, Section 5. So let's take a look at our first problem here, and it says, find the slope and y-intercept and then graph the linear equation. So the first thing I'm going to end up doing is looking to see if y is by itself. And yes, y is by itself in this problem, so the y-intercept is this term right here. So this is my y-intercept, so y-intercept equals, the variable b is what we end up using, and that is -3. So I'm going to go down 3 spaces on the y-axis, put a dot there, and then use the slope. The slope is this other term here, 1/2. So this represents my slope. So I'll say the slope equals m is the variable we're going to end up using, and it's 1/2. So that just means I'm going up 1 space from the y-intercept over 2 spaces to the right. That gets me on the line. I can also go the other direction, down to the left. It gets me on that same line. So I'll go ahead and draw the line between those points, and there it is. Taking a look at our next one, it says to do the same thing. Find the slope and y-intercept, and then graph the linear equation. So on this one, we've got an extra step. So I need to get the y by itself. And so what I'm going to end up doing here, I'm going to move this graph down just a bit. I'm going to end up moving that 1 over to the other side to get the y term by itself. So if I do that, I'll subtract 1 from all sides, and it leaves me with this, -1 5/10 x minus 1 equals y. Well, I could rewrite this the other way with y on the other side of the equal sign, and it means the same exact thing. So now what I want to do is start with that y-intercept. And so the y-intercept, which we're going to use b as the y-intercept here, is -1, where our slope is represented by -1.5. Now that's kind of difficult to graph because you got to go up 1.5 spaces, but I could show you how it ends up working. We can start here with the y-intercept. We can go up 1.5 space and then over 1 space to the right, because whenever you've got a slope, you can always write it over 1. But there's another way to do that that might be a little bit better. At least it gives us points where we don't have to worry about being halfway in between. We could change this to an improper fraction. And so -1 is the mixed number form, and if I go ahead and modify that, that would be -3/2. And so let's go ahead and fix that point. I see a mistake I ended up making. I used a positive slope, so I'm going to go ahead and tap that out and go to the negative slope. So again, it was -1.5 over 1, so I should have gone down 1.5 and then over 1 to the right, and that would get me on that line. Notice how it should be a negative slope as we go downhill from left to right. So again, I was talking about this -3/2. It's the same thing as -1.5. I could go down 3 spaces and then over 2 to the right. And you see I end up on that line. You could see that it works using that -1.5 as well. See, if I go down 1/2 and then a whole space is -1.5. Over 1 gets you right on that line. Now, if you run out of room that way, you can always go up, and then to the left gets us on that same exact line. And so there it is. Lots of points to be able to draw a line through. So again, negative slopes, downhill from left to right. Taking a look at our next problem, it says a skydiver parachutes to the ground, the height y in feet of the skydiver after x seconds. Well, that helps us right there because it tells us what x should be. X should be number of seconds. And then we have the y value, and y is represented by height. So I'm going to end up putting the height along the y-axis, and the height is in feet. And so it's always nice to know what units they're dealing in. And now we want to figure out what values we should end up using for our intervals. And so I'm going to do that by taking a look at the intercepts. I'm going to find the y-intercept first, and looking at the equation, if I set x equal to 0, so I'm going to find that y-intercept, I'm going to set x equal to 0, I've got just y equals 2,000. And that makes sense. In the slope-intercept form, the y-intercept is always the number being added to x. So I've got to be able to go 2,000 feet up. And so when I look at this, I think since I only have 1, 2, 3, 4, 5, 6, 7, 8 spaces, I think if I end up going by 250s, it'll get me right up to where I need to be. So if I put 500 right here, and then this would be 1,000 feet, this would be 1,500, it would put 2,000 feet right at the top of our line, of our graph. And so now let's figure out the number of seconds. So I'm going to do the same thing. I have to find the x-intercept anyhow, so let's go ahead and find the x-intercept now. We're going to set y equal to 0. And so when I do that, I've got 0 equals negative 20x plus 2,000. So I can go ahead and move this 20x over by adding it to the other side. And now I've got 20x equals, and that equals 2,000. So when I go ahead and divide by 20, I'll end up canceling out one of the zeros here. 2 into 200 goes 100 times. I need to be able to go 100 times over. And so I think I'll end up going by 20s here. So 8 doesn't go into 100 evenly, so I guess I'll just go by 20s. So I'll call this one 20 seconds. This would be 40 seconds right here. And this would be 60, so 80. And then my 100 will end up being right there. And then, let's see, yeah, we'll go ahead and do that. And then we'll put 120 right there. So 20, 40, 60, 80, 100, and then the 120. So I know I've got 100 right at this point here, and then 2,000 up at this point, and the line's going to go straight down and touch that value right there. Hopefully your line looks a lot straighter than mine, and maybe I can fix that, see if I can do any better than that. So going downhill, looks a little bit better. Definitely curved a bit, but hopefully it's a nice straight line. Use a ruler when you do it, and let's go ahead and interpret some stuff. So we labeled the graph, and we've graphed the equation. Now we're going to interpret the y-intercept. So the y-intercept is our initial value. So y-intercept equals the initial height of the skydiver, where the skydiver took off. And so he was either in a plane or on a mountain, wherever he was 2,000 feet up above the ground. So initial height of the skydiver, 2,000 feet above the ground. Then we found out what the x-intercept was. The x-intercept is time. So at this time, at 100 seconds, he is 0 feet. 0 feet, so that means he's on the ground. So the x-intercept is 100 seconds, which is the time it took him to impact the ground. So the time in air is another way to think of that. So time in air. And the next one would be the slope. And so I didn't use the slope in this case, but we can find the slope by just looking at this. So negative 20 is the slope of this line. So let's take a look at what slope is. Slope is the y over the x. So negative 20, looking at the y values, those are feet. And then over x, well, x is 1 second. Negative 20 over 1 is negative 20. So the negative sign means I'm going down. So this means I end up going down 20 feet per second is what that represents. So those are the three components there. Let's take a look at our next problem. And it says to write the equation in slope-intercept form, then graph. So I'm going to do the same thing. We're going to end up starting by moving that x term over. And so we're going to subtract the 2x from all sides. Now when I do that, I'm still left with this 3y equals, and then I'll rewrite negative 2x plus 6. So from that point, I'll divide by 3. I divide every number by 3, and I'm left with y equals negative 2/3 x plus 2. So this is the slope-intercept form. So I've got my y-intercept, and so I'll say b equals 2. So that's the y-intercept, and then m. M is negative 2/3. So I'm going to go up to 2 on the y-axis, and then I'm going to use the slope, down 2, right 3. Now I'm running out of room that way, so I can also go the other way. Up 2, left 3. Gets me on that same line that I can draw a line through. Well, looking at our next problem, it just says graph using intercepts this time. So when I'm using intercepts, I'm going to find out what the x-intercept is, then the y-intercept, and then plot those 2 points and draw a line between them. So I'll start with the x-intercept. When I'm finding that x-intercept, remember you set y equal to 0. So it's going to cancel out that negative 2y, and hey, I've got my answer right away, negative 2. So I'm going to treat that as an ordered pair, negative 2 comma 0, because that's what y is. Y was 0 when x is negative 2. So for the y-intercept, I'm going to set x equal to 0. So when I do that, I cancel out the x term, left with negative 2y equals negative 2. Dividing by negative 2 gives me y equals 1. So this point is 0, comma 1. So let's plot those. The x-intercept is on the x-axis. It's where it crosses the x-axis. The y-intercept, where it crosses the y-axis. And then you draw the line between those 2 points. So taking a look at the next problem, it says you have an equation. You have $8, You have $8 to spend on apples and pears. Label and graph the equation, and then they give us the equation where x is the number of pounds of apples. Okay, so x is pounds of apples. Let's write that down along our x-axis. Number of pounds of apples. It's really important to label your graphs so that you can interpret them later on. Y is the number of pounds of, and then pears. Alright, so now we have to interpret our intercepts as well. So let's start by taking a look at finding what those intercepts are. So I'm going to find out what the x-intercept is to start with. So the x-intercept, remember I set y equal to 0, and I cancel out that y term. I'm left with 1 6/10 x equals 8. So I divide by 1.6, and x is going to end up equaling 5. So 5 it equals. And so x equals 5, and that means if I go up, and I think I'll just go up by ones in this case. This is 2, 4, 6, so we're right there. So what that means is the number of pounds of apples, notice that's 0 right here. And our pounds of pears is 5. So what this 5, this is the x-axis here, so let's fix that real quick. Delete all that stuff. Oops, I don't need to delete that 6 though. So let's go on the x-axis. So 2, 4, 6. So right here at positive 5, x is the number of apples. And that means we have 0 pounds of pears. So x equals 5 means we can buy 5 pounds of apples if we don't buy any pears. So 0 pears, we can get 5 pounds of apples, and that's what that x-intercept represents. Let's find the y-intercept now. So for the y-intercept, we're going to set x equal to 0. So I've got the equation right up here. It's we're going to set x equals 0, so it's just 2y equals 8. And so I'm left here dividing by 2, I'm left with y equals 4. And so we have, which means we can buy 4 pounds of pears if we don't buy any apples. And so those are the definitions of the x and the y-intercepts. So we get to plot those 2 points and then draw the line between them. Now let's take a look at our next problem here. And here it just says the formula is used to convert Kelvin into Fahrenheit, and it gives us that formula. And we're supposed to take, if the temperature is 59 degrees Fahrenheit, solve for K. So we're just going to substitute. Substitute 59 in for the degrees Fahrenheit into that variable, and I'm going to go ahead and put 59 minus 32, and then plus the 273.15. So I do that work, and this gives me 27 that I need to multiply by 5/9, and then plus the 273.15. So when I do some cross-canceling here, I'm left with 3 left over, so that makes 15 plus 273.15. And I go ahead and add those two numbers together, I make 288 and 15/100 Kelvin. Well, looking at our second to last problem, it says the vertices of the figure given, find the coordinates. So they want to know the coordinates of the figure after the transformations. So there's 2 of them. We're going to take these points and reflect them across the y-axis first. So -5, 3, and that represents A. And then we have -2, 3, that is B. Then we have -2, 1 is C, and -5, 1 is D. So we're reflecting this image here across the y-axis. So across the y-axis, it goes this way. So we end up having a point here, 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 and here. So that's across the y-axis. And then we're going to end up labeling out what those points are. So you see how A prime is going to end up being, and then I'm going to go ahead and write down what it is here. Even though these aren't the solutions yet, I'm going to write this down. You'll see why in just a moment. So A prime, that point is 2, 3. And then B prime, and this one is, B prime is right here. And this one will end up being, I made a mistake already, that was A prime, so let's fix that real quick. Let's go back. So B prime is going to be at this point right here because I flipped it over, and so A prime is going to be further away over here. This will be C prime, and oops, I messed up again. There's C prime, and this one is D prime. D prime right here. And so again, C is going to be 2 spaces from the axis, the y-axis, and then 2 spaces over. Same thing with B, A, and D. So now I'm going to plot or write down what those points are. So A prime, that point is 5, and then comma 3. So notice what happened. It just switched signs. The x value switched signs. So B prime is 2, 3. So again, the point's the same. It just switched signs. The x value just switches signs. C prime, it is 2, 1, and D prime is going to be 5, 1. Now they're asking us to dilate with a scale factor of 2. That's going to just make it bigger. So when I dilate, I'm going to multiply the x and the y by 2. So I have to multiply this by 2 and multiply this value by 2. So everything gets multiplied. So from here, I can just write down what those values are. A double prime, it's going to be 10, 6. And then B double prime, it's going to end up being 4, 6. And then C double prime, that's going to be 4, 2. And D double prime is going to be 10, 2. And so all they really wanted here were the coordinates, is what they said. The graph helps us try to at least figure out where things go, but then from there, if you can just write down what those coordinates are. So taking a look at our next one, it says the slope of the roof is referred to as the pitch. Your counting requires at least 1.5. At least means that amount or more. So that amount or steeper. Steeper means a number closer to 1. And so it says this within specs. So explain whether this one is within specs. So remember, our slope is the rise over the run. And so it's rising 4 units and it's running 12. So if I was to reduce this fraction, take out the common factor of 4, I'm left with 1/3. So this slope is 1/3. You can do it one of two ways. You can compare, is what we're doing. We're comparing 1/3 to 1/2. And so I can either change them to decimals, which would be 0.5 or 0.3 repeating, and see that it's not within specs because 0.5 is greater. And I did that by just dividing 3 into 1. And so it doesn't go into the 1, but it goes into 9, or it goes into 10 9 times, or 3 times, and then that 1 continues to repeat. And so you can see how I got that. Or I can change them so that they have the same denominator. I can multiply by the other's denominator, and you can see how 3/6 is greater than 2/6. So either way, you'll need some sort of work, either one of these two ways, to show me that one is steeper than the other. And in this case, we would say the roof is not within specs because the slope is less than 1/2. And so you got to give me an explanation of why, and we did that because it had to be at least, and at least means greater than or equal to, when this one is less than. And so make sure you give me showing me how. You can't just say that 1/2 is greater than 1/3. You got to prove it either in the decimal form or coming up with a common denominator. So those are the problems that you'll see on this week's test. Good luck.